Okay, first set of examples here are all about changing the amplitude and seeing how that impacts the graph and the frequency. So stretching and shrinking of both amplitude and frequency. That's what we're going to start with. So we're going to work through examples 1 and 2 on page 15 of the note packet, and then you guys will have a chance to do the practice for those before the answers go online. All right, you're going to do these exactly the same way that you will do your homework assignment as well. You're going to fill out all of the information and then do the graphs by hand. So we'll go through all of these, but email me if you've got any more questions. Okay, so what we want to do with example 1 is we want to determine all of the information that relates to this equation for sine of x, and then we will graph the function. So sinusoidal axis, that remember is the number we're adding on the outside. It's the shift up and down. That is 0. We're going to write it as an equation because the sinusoidal axis is going to be the horizontal line that divides the graph in half. In this case, that is the line y is equal to 0. It would be like saying 4 sine x plus 0. Okay? All right, the amplitude then is the number in front of sine or cosine. That is the value of a. Our amplitude here is 4. We will always make the amplitude positive. So reflections will come later. If we've got a negative in the front, that means we've got a reflection, but we will always state the amplitude as a positive number. All right, so maximum then. To find the max, you take the sinusoidal axis value and you add the amplitude. If you do this every single time, especially when we start to see vertical shifts, it's going to make your life a lot easier. The minimum then will be the sinusoidal axis value minus the amplitude. So our minimum is -4, our maximum is +4. Our frequency is the number on the inside in front of x. So the number on the inside in front of x, lucky for us, there is none, it's just 1. I don't know why I changed colors there. Let's see, 1. And then the period is always 2 pi over the frequency. So in this case, it's just 2 pi. You don't have to worry about showing the work if you guys can do this in your head. We're going to stay in radians. Part of the reason I want to stick with radians is I want you guys to get more and more familiar with working with radians. It becomes really important next year and in calculus. Now, the subinterval length is always the period divided by 4. There are 4 subintervals in every cycle, and we're just going to simplify that. Do not leave me with unsimplified fractions. Pi over 2 is our answer there. And then our phase shift, that would be the shift horizontally. So the shift left and right, that's on the inside, what we're adding or subtracting to x. In this case, it's 0. That would be like this, 4 times the sine of x minus 0 or x plus 0. Okay, so next up is the key points. We're going to list the first 5 key points always. Now, the first key point always starts with the phase shift. So I'm going to make a note there. That is always the phase shift. And then we count by the subinterval length. So the way that we're going to count along the x-axis is always by the subinterval. So I like to do all of the x values of the first 5 key points and then do the y values, but you can do it however you'd like. Okay, so our subinterval length is pi over 2. So 0 is our phase shift. The next one is pi over 2. Then after that, it's going to be 2 pi over 2, then 3 pi over 2, and then 4 pi over 2, which simplifies to 2 pi. The very last thing we have to do then is determine the y values, and those are going to come from those key points, the minimums, the maximums, and the sinusoidal axis. So go to what we're graphing. We are graphing sine. The order of key points for sine is always axis, max, axis, min, and then we end back on the axis. So our first key point will be on the sinusoidal axis. That has a value of 0. Our next key point is going to be at the maximum. That is 4. Back to the axis, 0. Our minimum is -4. And we end on the axis back at 0. All right, next we're going to actually scale the graph. So I am going to first label and draw the x-axis, and then later we'll do the y. Okay, so don't do the y, do the x first. I'm going to pause. You guys work through that, and then I'll put the answers up. All right, so I've got the x-axis totally labeled. Again, we're counting by that sub-interval length starting at the phase shift. So the phase shift is 0, and then we're counting by pi over 2. And then I made sure that I included a negative value as well. We'll talk about that as I go to hand graph it. But when you guys go to hand graph sine and cosine curves, you want to get everything on the x-axis labeled first, and then you draw in the y-axis where it fits. And that becomes way more important when we start to shift things left and right. But for now, the y-axis fits nicely right there at 0. So I'm going to scale that. It looks like I'm just going to pick some points and call that 4 and negative 4. All right, so all you need on the y-axis is your max, your min, and your sinusoidal axis, which is 0 in this case. Okay, sinusoidal axis is the line y is equal to 0. I'm going to sketch that with a dotted line. This is the line that will divide our graph in half. Now we're starting at the phase shift, which is 0 radians, and we're going to graph the key points in order of sine. So at 0, we start on the axis, and then the next key point over on the x-axis, we go to max, axis, min, axis, max, axis, min, axis. Okay, so I've got all of the points along the positive x-axis. Now, I do want you guys to get used to graphing a negative value as well. So that negative pi over 2, take a look at the way that the curve is going. Now, from that point at 0, 0, we'd go right to get to the maximum, which means to go backwards, we're going to go left and we're going to go down to the minimum. And then all you guys do is sketch in the curve, make it really nice and curvy. Don't make it pointy. It's not absolute values. So a nice, really smooth curve, and then always include arrows on the two ends because remember, the domain is all real numbers. Okay, so that is our first example. Take a second, pause, make sure everything is good. We're going to move on to example 2 now. All right, second example for shifts, and then you guys are going to practice the for you to-dos. We want to identify the amplitude, period, all of that information for the graph 1/2 cosine 2 pi x, and then we will graph this by hand. Okay, sinusoidal axis, again, y is equal to 0. The sinusoidal axis comes from that vertical shift. We're not adding anything to the end of this. The amplitude is the number in front of cosine. This time the amplitude is 1/2. Our max is then 0 plus 1/2. It's the sinusoidal axis value plus the amplitude. Our maximum is 1/2. Our minimum is the sinusoidal axis value minus the amplitude. So negative 1/2 is our minimum. Our frequency is the number in front of x. So if we take a look at this function, 2 pi, we have to take it all. That is what is sitting in front of the x variable. And our period then is always the standard period 2 pi divided by the frequency. So our period here is 1. Our subinterval length is always the period divided by 4. And our phase shift is 0. We're not adding anything to x. We're just multiplying that. That's the frequency when we multiply to x. The phase shift would come when we add or subtract values from x. Okay, first critical point always starts at the phase shift, which is 0 in this case, and then we are going to count by the subinterval length. So 1/4, 2/4, 3/4, 4/4. Those are the first 5 key points. Now we're talking about cosine. So cosine, the order of key points, always starts at its max, axis, min, axis, max. If you can memorize that order, you'll be able to get all of the points for cosine. So at its maximum, which is 1/2, that's the first key point. Then we drop to the axis, which is 0, the min, negative 1/2, back to the axis, and then we end on the maximum. All right, again, I'm going to draw in the x-axis. I'm going to fill out all of the information along the x-axis, making sure that I include at least one negative value, and then I will drop the y-axis after that. Okay, we're back. We've got the whole x-axis scaled using the sub-interval length, and then I dropped the y-axis in completely when I was completely done with the x-axis, and I've made sure that I've able to fit the maximum and the minimum and that sinusoidal axis value on the y-axis. Those are the only 3 points you need on the y-axis. I made sure that the graph is going to be relatively spread out. I don't want you guys to turn in graphs that are super, super short and tiny, and like you guys have to use like 0.03 lead in order to graph them. So try and spread the graphs out as much as possible. Okay, cosine. That is what we are graphing. We're going to start at the phase shift, which is 0 radians here. And at 0 radians, we always start at the max for cosine, hit the axis, go to the minimum, axis, max, axis, min, axis, and then the last point, we're going to end up back on the maximum. And then again, look at the pattern of points to graph that negative value. That negative value then is going to go back down to the axis and sketch your curve. Again, it is not absolute value curves here, people. Do not do super jagged curves. I don't want V's. I want nice U's. And that is it. First set of cosine and sine curves where we're stretching and shrinking.